the seminar on thought leaders in data science and big data analytics at Berkeley's iSchool. Today, it's a real pleasure to have a really distinguished speaker, Hugh Williams. Hugh's done it all. He's a professor, and you know professors well, but not being content with that and doing things there and having written 100 papers, a few books, and so on. He went on to create much of the image search at Microsoft, and then set up, all of you hear about experimentation, digital marketing, and eBay is very famous for this, right? So he was the one who created the whole culture and the setup there, and he'll talk more about that today. And then he went on to be SVP at Pivotal into all these Internet of Things type of things. So, and now he's on to even more interesting pastures and new things. He's an entrepreneur and an entrepreneur, right? Yes. So without further ado, I'm going to let him take over. And you're going to have lots of fun. His talk is always fun. But then you'll get another hour of questions. Hugh?
Cool. Thanks, Ram. Appreciate it. I've got that. All right. I've really been looking forward to speaking to you guys, and particularly to interacting with you a little bit later on, and we can talk about anything you want to talk about after we sort of get through the formal part of the talk. There's some contact information for me. Don't be shy. If you want to get in touch, it's pretty easy. Be happy to hear from you afterwards and answer any questions that you might have. Ram just did a really good job of this, so I'm not going to dwell on this too much. But I thought it might be useful just to sort of give you a little bit of context of who I am and what I've done. I did the craziest thing out of college, which was at the end of the 80s. So I'm quite old. And that was, I did a startup straight out of college. That was very unusual back then. And they weren't even called startups back then. They were called companies. So I did a company. This is pre the web. Interesting time. I had a lot of fun building software with friends, and some good stories in there that you can feel free to ask me about later on. I then fell into doing a PhD in computer science. I sort of got interested in computational biology before it was called computational biology. It was just called computer science with biology stuff. And got really interested in that, did a PhD in computer science, got really interested in search engines after that, stuck around in the university system, and eventually became an associate professor in information retrieval, which was a really fun ride. As Ram said, wrote a few books, a few papers, all that kind of stuff that you do. And then things got kind of interesting. So I was a search engine guy. If you think back to the mid-90s, if you still remember those, there was this kind of search engine war going on back then between guys like Excite and InfoSeek and Alta Vista and these sorts of folks. And nobody was making any money. Nobody really knew how to monetize search. This young upstart company, Google, came along, had a better search engine, but I think folks still didn't really know how to monetize that. That's probably the reason I turned down their job offer, which I probably should have taken in 1998, because I'd probably be the richest person you've met for a while. I didn't take that, but I stayed in the university system and got more and more interested in search engines. And that kind of leads us to the trip to Microsoft. When we got to the middle of the 2000s, I think it was 2004 or so, Microsoft decided that they wanted to get into the search game. Very ambitious. They really wanted to put together a world-class team to go beat Google. I was really lucky to be really early on that team. I moved my family from Australia. You can probably tell I'm not from here originally. Moved my family from Australia to Redmond, Washington, joined the very early fledgling MSN search, and had a really fun ride building image search, video search, news search, and lots of the web search product that you see at Bing. Grew this crazy team from me and one other guy to over 300 people in a few years. Had a real blast. Then there's another long story I could tell you later on if we get to question time, where I landed at eBay, nominally to look after the search engine team there and help them get that back on track. I'm going to talk a lot about search today and experimentation in search as part of the talk. But again, we wound up in a pretty large executive role at eBay, managing most of the things that you see on the site. So when you go to eBay and use the website, I was lucky enough to be part of the team, lead the team that did most of that work. Then went to Pivotal, and now I'm unemployed. And happily unemployed, really enjoying spending spending time with my family, doing some consulting, some advising, getting a chance to speak, and thinking very seriously about doing my own company, going back to my roots and doing a startup, and this time it'll be called a startup, not a company. So pretty excited about that. Yeah, that's it. Anything's possible.
The reason I say this is I was talking to Vishal Sikka at Stanford just after he stepped down as CTO of SAP. And a week later, he's already a CEO of Infosys. So.
Yeah, things happen. So we can talk about this a little bit later on if you've got any questions, if you want to sort of talk about the corporate world, the university world, and innovation and search and any of those kinds of things. I'd love to have a chat about that. But what I'm really going to talk to you about today, maybe going back to the first slide, is sort of really knowing your customer. And this has a real sort of large consumer internet flavor to it. So what I really want to do is share with you how the large consumer internet giants go about understanding their customers and making decisions. So I thought the place to start would be to sort of talk about quantitative understanding. So, you know, in a quantitative way, how do the large internet giants go about understanding what to do on behalf of their customers? So I'll just start with some real basics. I think this is pretty 101 stuff, and I'm sure all of you are well versed with this, but it's probably wise to just sort of set some common ground. What the large internet giants are doing all day long is they're dividing the population of customers that they have into tests and controls. Traditionally, I think these days they tend to have more than one control, so that you can compare the controls and say, did this experiment proceed in a sane way? If the controls are very different, then you know something's broken, and that's useful to know. I've certainly run lots of tests in my career where I've been really excited by the results and then figured out later on that I'd actually broken something in the experimentation and the results were incorrect. So one sort of nice safety net thing you can do is have more than one control and compare the controls and make sure they're not statistically significantly different in their behaviors. So there's controls and there's tests. One or more populations of the users are put into tests. Data is collected from the populations of controls and tests over some period of time, and we can talk about sort of time a little bit later on. The experiment then ends. We then go and compute some metrics, and in industry you like to sort of misuse this term metric to mean numbers, but we throw around this term metrics. I know that that's not the correct scientific definition of metric, but that's what we call them. And we compute some confidence intervals, and then we make some decisions after we've understood the results. And I'll give you a real-world example in a moment of how that might proceed. On any given day, large internet companies are running many experiments. It could be tens of experiments. It could be hundreds of experiments. It could even be perhaps thousands of experiments. It is very, very likely if two of you are sitting here in this room today using the same internet website, and in many cases the same mobile app, that you'll in fact be in different experiments and you'll in fact have a subtly different experience. You sometimes might see this in a jarring way where you're at home with a friend or a family member and you say, hey, check this out, and they say, I don't see that. So sometimes it can be quite jarring and you can really notice. A lot of the time it's very, very subtle, and it's something very, very subtle that's being tested. But it's very, very likely, or indeed it's highly unlikely, that the person sitting next to you is going to have exactly the same experience that you're having. You could be in more than one experiment. That's generally true. If you think of sort of the population of users, you sort of say, well, there's 100% of users. At any given time, there are usually more requests to run tests than there are users available to put into those tests. The tests have to have some minimum population size because you have to compute some confidence interval so that you can discern between the populations and make some decisions. So you can't have sort of a population of one. You have to have a population of some significant size so that you can experiment on the groups. So when you run out of sort of users to segment, you have to start making decisions about putting users in more than one test. And that is, that's not a science, at least it's not as far as I know. So there's lots of meetings that go on in internet companies saying, well, I guess if we put those users in the experiment where we show them a different cart icon for their checkout process, it'd be okay to also have them in a different homepage experiment. That'd be okay. It's pretty unlikely if they're in those two experiments, that those experiments are going to interfere with each other in any meaningful way. It seems unlikely that if somebody sees a different cart icon, they're going to behave differently on the homepage of the website. Seems reasonable, so let's agree that those experiments don't need to be separated. We'll agree that they're sort of orthogonal experiments, and that's okay. So there's a lot of kind of judgment calls going on, saying what's orthogonal, what's not, what would interfere, what wouldn't. And it's, as I say, certainly not a science, more of a sort of a discretionary choice. But the end result for you as a customer, of course, is that you're very likely in more than one test. You could be perhaps in 10 tests at any given time. All rules go out the window when the tests are really sort of short sanity tests. It's pretty common in a large company to want to run a test for 10 minutes just to make sure it's kind of working. The data's flowing. It looks like it's really worth running this for a day or a week. If that's the case, then typically, folks won't put a lot of experimental design into thinking through the orthogonality or relationship between the tests. They'll just sort of throw some users in it for a few minutes to see what happens. There's typically a small population of users reserved for that, so you're not interfering with long-running tests that are out there right now. So I wanted to get a little bit practical about this. So there's sort of some sort of mechanical things. I'll just tell you a little bit of a story about eBay. I've shared this slide publicly before, so I know the guys will be okay with me sharing it one more time. It conveniently has the y-axis deleted. Don't ask me what the numbers are. It's very much a corporate kind of slide. But there was a really good story about eBay's turnaround. So when I joined eBay in 2009, the company was in a tough position. If you kind of fast forward to sort of 2012, 2013, it had kind of emerged again as a successful company in the valley. Stock price was up. The company was growing faster than e-commerce was growing. Lots of good things had happened. And so you could ask the very valid question. So what happened? What actually materially turned the company around? Well, I can answer from the technical perspective. Of course, there's lots of other great business decisions and branding decisions and marketing decisions that were made along the way, internationalization decisions, all kinds of things. But I can tell you a little bit about the technical story that helped with that. So if you look over on the very left of this graph, what I'm trying to illustrate here is that a user on some time scale, let's say a month, spent a certain amount of money on average on eBay. And that's what's represented by that bar that's shown as 2010. If you kind of fast forward over to the right-hand side of the graph, you can see the bar's much larger. And so the story there is that people were spending a lot more on eBay per user in 2012 than they were in 2010. So what we did was we asked the question of, well, can we go back and look through all the tests and try and figure out what were the statistically significant tests that we ran, that we decided to ship to the customers, that contributed to that growth in the spending of users on eBay. And then we sort of grouped them into some buckets. And so what you can see here is that there's lots of tests around improving search. So improving search on eBay was a really significant contributor to selling more stuff and the turnaround of the business. I don't think that's very surprising, because the primary task of something like eBay or Amazon is to connect buyers to sellers. And the primary way that they do that is by searching for the things that they want to purchase. So improving search seems like intuitively like something that would work, and indeed that's the largest block besides other, which contains a bunch of smaller things that contributed to the turnaround of eBay from a technical perspective. The second largest block was better imagery. Again, you could, in hindsight, which is 2020, you could say, well, that sort of makes sense. If the images on the site are prettier, larger, better reflection of the items that customers are purchasing, more attractive, those kinds of things, easier to understand as a customer, perhaps people would buy more. And that indeed turned out to be true. So there was lots of experimentation around improving imagery at eBay, and I'll show you one of those experiments in a moment. Better merching, so by which I mean, people who bought this, bought that, people who viewed this, bought that. Based on your previous behaviors, you might be interested in the following things. So this sort of merchandising recommendations work was a pretty significant factor. Lots and lots of experimentation and testing around that. And then the last sort of one besides other was simplifying flows. And again, if there's less clicks and pages to achieve the task that you want to achieve, then it seems intuitive that folks would be happier and purchase more. So things like simplifying the checkout process, making it easier to go from putting things in your cart to actually having completed the purchase, is a very significant part of the turnaround story at eBay. But I guess the thing you should really take away from this slide is that all of this was all of these changes in the product, the sort of continuous shipping at eBay that drove the turnaround from a technical perspective, was underpinned by this sort of A/B testing framework that we just talked about over the last couple of slides. I put two things in red: better search and better images, because I wanted to talk a little bit more about both of those. So here's an example of an image experiment that was actually run that actually was a pretty significant contributor to that turnaround story. It's actually a very simple test. One of the really smart folks on the team said, I wonder what effect increasing the image size would have in the search results on people's purchase behavior. So you can see down the bottom the control experience. You'll notice that sort of towards the left of that picture there's sort of some sort of earring type things and a watch. The images are relatively small compared to the test experiment, which is shown up on the top left. So you can see there's sort of larger picture of earrings and a larger watch. That turned out to be a really important test and really changed people's purchase behavior. We'll come back and talk about that particular test in a moment. But there's something that that was actually out there in the wild. I think in that particular case, several percent of the customers were seeing large images, and the majority were seeing the control experience. I've talked about many of the things already on that graph that improved search at eBay. So you just saw an imagery example. I talked a little bit about simplifying flows. It also turned out that sort of reorganizing pages so that things that are more frequently used are located in the right place. Things are intuitively grouped. There's less clutter. Controls are more intuitive for customers. It turned out that was very important in that search turnaround block. Optimizing the page. We actually refreshed the page, gave it a new kind of look and feel that was more modern. And then speed turned out to be a really big deal. That's something we could probably talk about a little bit later on, about the importance of speed in mobile applications and on the web to retaining customers and driving purchase behaviors and those kinds of things. Speed is very, very important. From a sort of science perspective, from sort of really altering the relevance and functionality of the search engine itself, there was a whole bunch of buckets of things that were done. I won't go through each of those, but I'm going to give you an example of that first bucket, this thing called query understanding and rewriting, just to give you sort of a sense of the kinds of things that went on at eBay and were tested using this experimentation framework. So here's the idea. If you go back to 2009, if we could sort of do a wayback machine and use eBay's search engine from 2009, you'd find it was very, very literal. By which I mean, it found whatever you typed. So if you misspelled something, it'd find things that were misspellings. There were lots of stories back then about you could get a bargain by misspelling things like Palm Pilot as Plan Pilot. So, and lots of sort of smart customers would do this. So they'd wake up every morning and they'd try a few common misspellings. They'd be the only customers retrieving those items. They'd buy those items at a cheap price because they didn't have the right volume around the auction or whatever it was, and they'd hit some bargains. So if you went down to your local used bookstore and got an old eBay for Dummies, there were lots of tips about how to sort of search for things that are incorrectly spelt and so on. So it was a very, very literal search engine. We decided that wasn't a good thing for customers, so we set about making the search engine sort of far more intuitive. So if you made an obvious mistake, the search engine would, as modern search engines do, quietly correct that and save you the embarrassment. And so to do a good job on behalf of the seller and to do a good job on behalf of the buyer. How do we go about that? There's a very long explanation to that, but I'll give you kind of the Cliff Notes version, if you like. What we did was we collected vast volumes of query data over a long period of time. So every query that's run on eBay is stored in a sort of data storage infrastructure, along with sort of all the behaviors associated with that query. what we did was we went back and we mined that data and looked for sort of associations and patterns. So things like synonyms, for example, and I'll give you an example in a moment. And what we were trying to do was really understand when a customer types something, what they really mean. And this was very, very useful because what the data had for us was real examples of customers typing a query, not getting what they want, and then refining that query and finding what they want. So let's say, for example, let's take that Plan Pilot example. You can imagine that a good number of customers who aren't these sort of bargain hunter types might type Plan Pilot and then go, man, I only got 3 results. Oh, I see, I misspelt the query. Let me go back and change it to Palm Pilot. And so those users are leaving a record that when you type Plan Pilot, you don't interact with the search engine, you go and refine the query, and then you interact with the search engine. And if you get enough of that evidence, you can build up the belief that Plan and Palm are actually the same thing. And then in the future, when a customer comes back and types Plan Pilot, you can automatically correct that because you've got high confidence that that's not what they really meant. So you can do that at a vast scale. I'll give you a really practical example. So you might wonder, what is this thing? It's a very, very collectible Pilzlampe. So these are German mushroom lamps. So eBay's got some pretty eclectic stuff. This is a whole category of its own. I'm not sure if any of you have ever seen one of these or got one of these. I'm certainly not an aficionado of them, but these are collectible mushroom lamps. So let's ask the question of how do customers go about purchasing this Pilzlampe? Well, it turns out they do lots of different things. So the first simple thing they might do is they might just go to the search engine, type in Pilzlampe, and then buy one. So great. Turns out there's also lots of customers who type Pilzlampe, maybe a few other things, and then type Pils space Lampe, and then actually go and purchase things. So you can see, if you've got enough examples of that you might build up the belief that Pilzlampe without the space and Pils space lamp may be the same thing. Pilzlampe and Pilzlampen, Pils space lampen and Pilzlampe, you get the idea. So there's lots of examples of people trying different sort of permutations, if you like, synonyms for plurals, whatever they are, for this particular kind of mushroom lamp. And there's lots of people doing that, and lots of people doing that all the time. So if you've got this vast amount of data, then you can, as eBay has, discover that Pils space lamp and Pilzlampe are the same. You can discover that Pils and Pilser are the same, and Lamp and Lampen are the same. This isn't literally what eBay does at the bottom. It's sort of more figuratively what they do, but you could imagine if you had all this data, you distilled out these facts, then when a customer came along and typed any one of those things, they could type Pils space lamp, Pils lamp, Pils space lampen, Pils lampen, whatever it is they type, you could actually run this query or something like it that's at the bottom. So I've sort of expressed it as a Boolean query there, that it goes and tries all of the things that would retrieve all of the results that match that particular user intent. So, a significant improvement over the sort of more literal search engine from 2009, where it would only find what you literally said. It wouldn't find what you really meant. So, sounds like a great idea. Like all great ideas, it's fraught with all sorts of danger, and I can tell you lots of war stories of what goes wrong when you try and do this at scale. I'll give you a couple of examples. There's lots of folks out there who, know that CMU is Carnegie Mellon. There's also a small number of people out there who know that CMU is the Central Michigan University. Now, let's just think about those people for a second. So those people are going to a search engine, and they're typing CMU, and they're going, what's all this Carnegie Mellon stuff? Let me go and change that query, correct it, and make it Central Michigan University. So they're doing just what we talked about with the Plan Pilot example, right? They're typing something, they're not interacting with the search engine, and then they're very quickly changing it to something else and then happily interacting with the search engine. So if you're a little overzealous in how you sort of go about this approach that we've talked about, you'll build up the belief that CMU and Central Michigan University are the same thing. And then for the 99% of customers who type CMU, you're going to start showing them Central Michigan University things. And you're going to make the vast majority of the population, really unhappy with the search experience. So hard problem to solve. There's lots of people who type mariners, and what they really meant was Marines. And so they go and make that correction. Now, for any folks who are fans of the Seattle Mariners, they're not going to be pleased to be getting pages full of paraphernalia from the Marines. So you've got to be very, very careful. That's not actually a spelling correction. It's somebody who made a typing mistake from a correct word to another correct word. So it turns out context matters. This thing gets hard, and you need vast amounts of data and big serving systems to manage very large dictionaries. So it turns out that context matters. If somebody typed Seattle Marines, they probably really meant Seattle Mariners, and it's probably okay to correct that. But it's only in the context of Seattle. You wouldn't, again, want to take the query Denver Nuggets at eBay and decide that really was things that had the word Denver in them in the jewelry and watches category, the gold collectible category, right? Because the Denver Nuggets is a concept. So you can start making some really nasty mistakes at scale that are around edge cases that make this fairly problematic. The good news, maybe tying this back to the experimentation idea that we talked about at the very start, is that you see the problems you've created pretty quickly when you deploy the experiment or when you ship the final result, right? Because what you'll see is a change in behavior for a certain set of queries, or you'll see a change in behavior for a certain set of users. And so you can pretty quickly tell that you've kind of messed something up, and you can go and make a correction. So it's not all about working with this dictionary that you've created and trying to correct it and come up with clever algorithms and mine the data. It's also about taking that data to your customers and seeing what they think of the new data sets that you've created. So it's as much of an online problem as it is an offline problem to solve. So let's go back to the topic of experimentation again. I simplified things really, really conveniently on that first slide, the high-level test versus control type statement. Turns out it's much more difficult than that. Many users aren't logged in. Right? So if you use something like eBay, I forget the percentage, but it must be close to half the users aren't logged in. So it's pretty hard to put users into a population if you don't know who they are. So that's difficult. Lots of users use several browsers. I'm sure you're amongst those. I mean, I use multiple browsers or incognito tabs because I want to be logged in to Gmail twice or whatever it is. So that's very, very common. Lots of people use multiple devices, of course. So I might be searching for something on eBay or Amazon on my desktop, and then I might put it in my cart, and then later on, pull my device out while I'm walking along and carry out some other action with that, and then I might put that down and go back to my desktop. I regularly eat my breakfast with my iPad next to my computer and my phone in my pocket, and it's pretty common within a 20-minute period to use all three. So I make it very, very difficult for internet companies to experiment on me because I'm in multiple places at one time, and they have to segment all those spaces. The other thing that's really, really challenging is that you might put somebody in an experiment, but you have to later on understand that they're actually affected by that experiment. So if we go back to the example around cart, remember I mentioned at the very start, maybe we've subtly changed the cart icon in the checkout process. We wouldn't want to draw too many conclusions about users in the test without making sure that those users actually used the shopping cart and actually interacted with the shopping cart. Right? So you wouldn't want to make a conclusion about customers who just visited the home page and assume that that their change in behavior was because of something you changed in the shopping cart if they haven't actually seen the shopping cart. So there's lots of kind of validation that needs to happen later on so that you can at least believe that the customer was actually affected by the change that you made, that they actually passed through that change. We talked about interaction effects of changes. I talked about this kind of judgment call that you make, where you sort of say, well, it's okay to put them in two tests. Those tests probably don't interfere with each other. That often needs some careful understanding. And then metrics are notoriously noisy. So it depends on the kinds of behaviors that you're tracking. When I was at Microsoft working on their search engine, we had the luxury of being able to run very high volume, very short tests. Because search from the web search perspective is relatively simple, right? A customer comes and types a query, does something, and leaves. You get a lot of signal very quickly. At eBay, much more challenging because you're interested in things like purchase behaviors. And customers, don't buy that much stuff. I'm fairly sure that you run a lot more queries on Google each day than you do purchase things on Amazon. And so, there's much less signal that you give Amazon each day than you give Google each day. That makes the metrics very noisy. You need very large populations. It's hard to sort of state things authoritatively with statistical significance. You have to run much longer tests, those kinds of things. And then the most important thing is that any judgment call you make in the consumer internet space, you're making with some confidence interval. So you're computing some statistics. You're doing a two-sided t-test or whatever it is at the end, and you're saying, I'm 90% sure that the behavior I'm seeing is real. That means there's 10% chance you kind of messed it up. And you have to kind of think that through. So you've really got to think that through in the context of very large changes. Is this the 1 in 10? And is that okay if we make that mistake? And how high a confidence interval is high enough? How long do you need to run the test in order to make that decision? How fast do you want to be making decisions? Those kinds of things. It's a very, very difficult balancing act. Lots of other things go wrong. Got some more examples. I won't kind of drill through all of these incredibly slowly, but it's very hard to measure long-term effects. Right, most of these tests are minutes, hours, days, a couple of weeks. They're not tests that run for years or months. So I'll tell you a story on that one. I was at Microsoft when Microsoft rebranded Live Search to Bing. That was a big change. I don't know if you guys sort of think back and remember that, but it's a big change, right? So the most significant thing from a technical perspective was that the search results page, instead of having sort of navigational elements on the right, it moved them to the left. They later changed their mind and put them back on the right, but at that point in time, they were taking things like related searches that everybody was used to seeing on the right, and they were putting them on the left. Now you can't A/B test that kind of stuff, right? Because if I put you in a test where all your navigational tools are now on the other side of the page, you're just going to go, whoa, whoa. You're going to be disoriented for some significant period of time. You're not going to use those tools as you normally would. It's not a subtle change. And so, as a guy running the experimentation, I'm going to expect my metrics to tank, and I don't really understand when they're going to come back, and I don't understand, what decision to make and when to make that decision. So it doesn't always answer the questions you're looking to answer. It's a little bit like the second point here. It doesn't really measure the burn-in time. Customers take time to adjust to things. You have to sort of, think that through. It doesn't work well for large changes. It doesn't work well for very small changes. Right? So I spoke a moment ago about eBay needing relatively large populations to measure changes in purchase behavior. So you might sort of take from that it's going to be pretty hard to, say, run a test that tests the sort of grayness of a font's effect on purchase behavior. It's going to be a pretty hard thing to measure. Data sometimes becomes stale. What I mean by that is, we might run a great experiment at Halloween. We might have this Halloween experiment we want to run. And we're like, wow, we've increased purchase behavior by 1%. But is that an interesting experiment a month later? Is that still valid? I don't know. What effect that has on the marketplace a month later if that was a Halloween-specific experiment that we ran. Some effects are seasonal. It's an example of that as well. You don't understand what you don't measure. So, you're going to have a set of metrics you care about. There's some things you're going to track that you use to make decisions. They might not capture the change that you're actually measuring. So that's important too. Now, I'll come back to this last point. I think it's really important, deserves a bit more discussion later on. So let's just go back to that image experiment that we talked about a little while back. I showed you the two screenshots of eBay. So let's imagine, you're in the decision room. There's 3 or 4 of us in a room. We've set up a 1-hour meeting to talk about this test, and we've got in front of us the results of the test. What I'll tell you is that nothing is unambiguous. So here's an example. It's hypothetical of what might happen with that test. So we might be like, people buying more stuff. That's awesome. So customers are buying more. That's great. Well, we should ship this thing. This is awesome. The number of bought items is up. Well, that's great. But search results page views per visitor is down. So people seem to be sort of searching less or paginating through search less. Have we broken search? I'm not sure. Why did that happen? It turned out, and this part of the story is true, that if you have larger images, people take longer to inspect the results that you give them. They pay more attention to them. They click on them, and they paginate less. So they get a sort of a deeper understanding of the things you've given them rather than go, I don't know, next, which you might do with smaller imagery. But that took some time to figure that out. I mean, when we first sort of saw that result where, larger images is causing people to interact with search less, what's going on? View item views per visitor is down. That means that the number of items that users click through to from the search results page is down. So they're visiting less items. So I think you can perhaps come up with some hypotheses as to why that might be the case, but then a couple of the last 3 are sort of, and we're also making less money in another way. So we're making more money from people buying things on eBay, but we're making less money from ads. So we're showing less ads, and people are clicking on the ads less. So if there was one of the ads guys was in the room with us at this point in time, they're going, "Whoa, you're messing with my business. I got some goals I got to hit for the business, and you're hurting my business. It's great that we're selling more stuff. That's good for you, but I got goals to hit." So you can see it's not straightforward. And as I say, this test that I showed you was one of the sort of home run kinds of tests that was run over the period that I was there. But it's never ever a slam dunk as to what happened or what you should do when you get back the results from the test. Of course, the end result of this particular discussion was they shipped it, and imagery is now larger at eBay. But there was some digging to be done before the decision could be made. Let's talk about that digging for a second. I personally have the very strong belief that you shouldn't sort of look at some high-level distilled-out metrics and make decisions. You should actually understand what's happening under the covers. So I think folks who've worked with me have sort of learnt to come along with sort of the next level of detail in case I kind of ask hard questions about what happened in the experimentation. And these are the sorts of questions that I might ask. So I might say, well, that's great that people are buying more. On what devices are they buying more? Does this have more effect on mobile or more effect on web? And why do you think that's the case? Because, of course, we want to know. We want to know, is imagery more important on a mobile device or on a web device, equally important? The worst case might be that it's actually hurting purchases on, say, the mobile device, but improving it enough on the desktop that you don't see that pain you're creating on the device. So it's pretty important to cut it at that level. Which operating systems, which browsers. If I had $1 for every time in an experiment I've broken the experience in some version of some browser, I'd be a really rich guy by now. So, woohoo, that's an awesome test. Oh, why aren't the guys using IE6 buying anything anymore? I see the page doesn't load. So really important to check. Which channels? Is it customers who are coming through from Google? Is it customers who begin their session with that internet property as their home page? Who, from where, why, those kinds of things. Important to understand. Which pages is it affecting? So, Again, if I had $1 for every time we've messed this one up, I'll probably be rich, but I'll be doing okay. People come in and say, we changed the cart icon and people are buying more. And then you say, well, can you show me the results that shows that they're actually on that page and adding more things to the cart? And they say, oh, actually, that page didn't change. All the change is coming from logging in. You say, whoa, hang on, that doesn't make any sense. You changed the cart icon and now people are logging in more successfully. Okay, the test's broken. Something's really wrong. It doesn't make any intuitive sense. So I think you've got to kind of reflect on, did you see the behaviors you expected to see in the test from the pages you expected to see them from? So, does it make sense? I think is the sort of the kind of bottom line. Some other ways you might cut it: which customers, which categories, which queries, what kinds of sessions, types of pages or items, how does it affect other features? You saw an example of the other features one before where the imagery got larger, people were more successful with search, but they clicked on ads less and the company earned less ad revenue. So, there's these interesting interaction effects. I think, we often talk when we're analyzing experiments about where did you pull the clicks from? And often that's not a happy story, right? So let's go back to that cart example. If we put a big cart icon and everybody's adding things to the cart, that's the thing that's getting clicked on that page now. Where did those clicks come from? Did it hurt some other feature on the page? Did it stop people checking out and actually purchasing? They're now just adding more things to their cart and not completing the behavior? If so, maybe that's not a good thing. So where is that behavior actually coming from? What else could you compute to better understand it? And again, does it make sense? Are you seeing what you'd expect to see when you designed the experiment? Maybe just getting on the soapbox for a second before we completely change the topic and sort of talk about qualitative understanding of customers just for a little bit. I hate mean averages. Really, really hate mean averages. I think they always hide the truth. So I really like to ask questions like, so great, the test's up, that's fantastic news. How many customers were hurt by the test and what happened to them? Because I don't think I've ever seen a test where every single customer is better off than they were previously in the control. Right? You're probably going to see somewhere in the single digits of customers who are less successful completing whatever task it is than they were before. So what happened to those guys? And when you understand that, are you still okay with shipping the result? Or is that unacceptable? Is that something that you couldn't live with, that you've broken it so badly for that small fraction of customers? I also think that failure is the most interesting thing. I think, particularly in a corporate environment, everybody wants to succeed all the time and talk about how they're doing great things. I love a culture where you celebrate failure and you really sort of embrace what went wrong, because you can learn a lot. So if you go and look at the things you've broken or the things that aren't working, I think you have the best ideas about how to build the next set of features that you need to build. You don't learn much from looking at things that work. So you've always got to celebrate failure. And then, what can you learn from the success? What's the next thing you should do? I think with most tests, you don't want to sort of celebrate it and sort of turn the page and work on the next idea. You say, well, that worked, and that's cool. What else can we do? What else would we improve now that we know this is a promising theme of exploration? The imagery work at eBay went on for 4 years. Right? It started with, let's try bigger images, and that turned out to be a really rich vein of exploration, improving the imagery on eBay on behalf of the customers. It turned out to be a really big deal. But it takes a lot of tenacity to want to stick to that theme and keep working on it. Most people want to run to the next big shiny thing. So that's quantitative. Covered a lot of ground. Let me just talk about qualitative a little bit, and then we'll chat. How's that? So some qualitative things you can do. Well, I think the danger with computer science and computer scientists is they're a fairly introverted bunch, and they like to kind of fiddle around with machinery and sit at their desk with their headphones on and noodle with data. They don't really like talking to people much. I'm a computer scientist. I know from experience. It turns out it's really, really important to actually go and meet customers and listen to customers. I learned that particularly at eBay during my tenure there, that I could really have my mind expanded in really interesting ways by going around to somebody's house and watch them try and sell stuff, or watch them try and buy stuff. I think that's an incredibly powerful way to sort of get out of the ivory tower and learn what real customers are trying to do. Because often you'll find, you've built this super clever feature that you're in love with and the test tells you it's great, but then when you go and show it to a customer, they just completely don't understand it. Or you've made what was a simple task for them a much harder task. And there's something that you can fix to really make it a successful experience for them. I like surveying customers along the way. I hate those pop-up boxes that says, would you please answer a survey? Hate those. I think also they bias the results, but that's a topic for another day. But I think it's important to have some kind of tell us what you think link on your page and to capture some structured data and some unstructured data so that you can make better decisions, particularly when people are rapturously happy or really, really unhappy. I think it's really interesting to know why. You can do user experience research studies, so instead of going to the customer's house, you can bring the customer to you. You can give them a task to do. It's a little artificial. So I could say to you, would you please sell this iPhone? And then I'd watch you through one-way glass. You couldn't see me, and I'd sort of watch you, and I could see your screen, and we'd have cameras and all kinds of things, and I could do eye tracking and watch where you're looking and those kinds of things. It's a little artificial because I made up a task that you didn't want to do, and I'm paying you to do it. So you're sort of figuratively like a mouse in the maze, and there's a treat at the end. Like you're just going to keep going around until you get there. You're not going to give up and go, this is a stupid thing. I'm going to go to Amazon because I'm paying you. So it's a little, as long as you understand what the weaknesses are, it's a useful tool. And you can explore user data with tools. And again, like computer scientists tend to fall back to that one. They say, there's a way of not meeting customers. I can look at customer data and kind of visually see it. That's great. Didn't have to talk to anybody. But I think that's, it's also a useful adjunct to actually talking to real people. So let me just say a couple of things about inline surveys. I think you should capture as much data as you can without overwhelming the customer. I think when you give customers radio buttons, so you say things like, on a scale of 1 to 5, rate the following thing, you're going to get all 1s and 5s. You'll very rarely get 2, 3s, and 4s. They'll either hate you or love you, and you should expect that. So don't average it, because you'll come back telling me the score's 3.1, and I'll say, how many people voted 3? And you'll say, 6. And I'll say, okay, why don't you go and cut that data a little differently? Verbatims are where the gems are. So, the voting with the radio button sort of gives you a directional feeling for things, but actually going and looking at the text that they type in and mining that and understanding that's really, really valuable. And you can slice and dice that in lots of the same ways and have the same skepticisms and questions that you might have with the quantitative stuff we talked about a moment ago. Another sort of form of inline survey is human judgment. We could talk for an hour about how to do human judgment in search and the science of doing that. I'll just kind of simplify it for a second by showing you pictures of cute kittens. This is sort of, in essence, a basic version of what you might ask a customer to do who you're paying. So you might say to them, is this better than that? In the case of kittenwar.com, you're voting for the cutest cat. So you look at the cat on the left and the cat on the right, and you click on the one that you think's cutest. And from that they can discern what a cute cat is and the characteristics of cute cats. But effectively, that kind of thing goes on at a very, very large scale. In search engine companies, most search engine companies are making millions of human judgments per year about the relevance of their results, using techniques somewhat more sophisticated than this, but you get the idea of asking, is this better than that? Collect vast amounts of data. User experience research, as I said, watching the customers, using the product. You can ask basic questions like, are they behaving as I expected? Is my feature, when it's out in the wild, actually being used in the way we conceived it in the ivory tower? How do they feel about the feature? What's their reaction? Are they excited, disgruntled, find it hard to learn, easy to learn, powerful, not powerful? What happens with different customers of different levels of experience, from customers who are regular users of the site to customers who've never seen the site to customers who aren't familiar with using a mouse? What sorts of things happen to different types of customers? What were their reactions? And then, of course, in large companies you have large numbers of employees, so you can get those reactions from the employees as well as the customers that you bring in. I talked about exploring data using tools. Again, this is something that computer scientists love to do. Let me just show you one example of that in in the interest of time, here's a Google heat map. You remember before I said in the user experience research studies, you'll often set up some cameras and track how people's eyeballs move. From that, you can plot data like this. So, for a query, you can understand where they focus their energy. This is a pretty typical query. I think there's somebody here searching for George Brett, the baseball player. And you can see that they're spending most of their attention where you'd expect them to spend their attention on results 1 and then 2, and then you can see their attention fading away as you move down the page. And you can also see a brief glimpse over to the right to sort of check the ads out, and you can see relatively that they're more interested in the results than the advertisements. It turns out, this is very typical. There's kind of an exponential decay in the attention spent per result slot. So customers spend, almost no time on the lower results on the page. They spend almost all of their time on the top results of the page, and that's why, users perceive that a good search engine is good because it returns relevant results at the very top of the page. I'll tell you a little interesting thing, though. This is it's hard to see on this particular example, but what you'll see is that there's disproportionately more time spent on result 7 than on result 6. And you might say, it's a little strange. So, it decays down, and then there's this little bump, and then it decays down again. Why would they spend more time on 7 than 6? It turns out that 7 is the most frequently below the fold on the browser. So the customer scans the page, then they scroll, and then the top result is now result 7. So they spend a little bit more time on 7 than they do on 6, which is really, really interesting. And yes, I did run an experiment of switching 6 and 7 to see what would happen, but it's a long story. This is a session exploration tool. It's another way of sort of looking at how customers interact with search. In this particular case, you can see up the top here that a customer was clearly trying to buy a 120 they're going to convert a 220 volts to 120 volt transformer. They're really after one of those. So they started off by typing the query voltage converter, then they tried 220, 120 AC, then they tried 220 volts convert to 12 volts transformer, and so on and so it went. In the middle there, they got a little bit distracted and tried to buy a cast iron lamp, and then got back on the theme of trying to buy a transformer. But you can sort of see just by reading the set of queries that this customer typed how frustrated they were with search, and you can sort of see the problems they were having with the query modifications that we were talking about earlier when we discussed the pills lamp example. It obviously wasn't working well for them. And when you dig into the details of this one, which is what the bottom of this screen shows, you can see what items they actually clicked on and how they behaved and how long they spent on the items. So if you're working on the search team and you've got access to a tool like this, you can learn a lot about what's working and what's not working, and it'll probably give you some great ideas about what features you should go and build next. All right, I'm going to stop. Just a few more concluding words, just some sort of warnings, I suppose, about experimentation. Data won't tell you everything. It certainly won't tell you what you don't measure. I think you'll find, in the corporate world that folks want to set 1 or 2 big goals. They say, let's go and do these 1 or 2 things this year. We're going to drive these 1 or 2 things up. If as a technologist you get too obsessed with only those 1 or 2 things, you may make some bad decisions because you're not exploring some other metrics that are important to your customers. And ultimately customers are more important than executives in companies. We saw with that image example, you'll very rarely get an unambiguous picture. So you'll go and run experimentation, but you still need real experienced adults like you guys in the room to sit down and pull the results apart and actually make decisions. Right? Tests are not going to tell you what to do. They're going to give you information so that you can make a logical decision. I won't tell you exactly what to do. We talked about live search becoming Bing. There was no way to run a set of experiments that would tell you how to jump from the mountain that was live search, where it had been optimized using tests. There was no test that you could run that would tell you how to jump to a completely different mountain that was Bing. Right? You had to make a leap of faith to go and do that. So experimentation is not going to tell you how to make big innovative changes. It's going to tell you how to optimize on the little local hill that you're on today. It's not going to tell you when to take risks. If you want to take no risks, just do experimentation, and you'll just be optimizing on this little hill all day long. You'll never do anything substantively new. And of course, it won't tell you when to be decisive. So it doesn't solve all your problems. It just helps you make good decisions along the way. All right, so I'm going to stop there. Maybe we'll turn off the mics. I'll have a drink of water, sit down, we'll have a chat, talk about some other things for a little bit. How's that? Cool. Thank you.